Good evening.
Good evening, everybody.
All right.
Welcome back to show 9 of the Arduino Show.
Yeah.
Actually, small correction. 8. We're on 8.
Oh, okay.
But 8, 9, 10, doesn't matter. It's another show.
Yeah. So, tonight we are doing servos, which is right up my street because I like remote control vehicles, cars. I've done them since I was a kid, so tonight should be fun. But, we'll go through the chat. Do you want to go through the chat, Horlixs?
Yeah, I can do that.
Oh.
Okay, right. So we've got Gillian Milne saying evening, everyone. So hi, Gillian.
Hi, Gillian.
Hi, Gillian.
We've got D. Harris. Good evening, Alex, Mark, and young Jack. Hope you're all well. Thank you very much.
Evening.
Hi, D.
And D saying hi, Gillian Milne. Good evening. D. Harris. Good evening, all on this on the other side. There we go. DS Modz and Vintage. Hello, everyone. Hope you have a brilliant show. Thanks, Dave.
Hi, Dave.
Dave.
Crafty Chris. Good luck with the show tonight. Thank you, Chris. Hiya.
Hi, Christine.
Hi, Christine.
George Crafter. Good evening, everyone.
Good evening, love.
Hi, Julia. D. Harris, DS Modz and Vintage, and Crafty Chris. Good evening, both. Dano's Universe. Hello, everyone. Hi, Dano.
Hi, Dano.
Hi,
Says
Dano.
hi to Dano. And evening to Yorkshire Crafter. And Dave Matt Bill says, good evening, everyone. Enjoy your electrics, guys. Thank you very much.
Evening, Dave.
And Dave Mack saying, evening, D and Yorkshire Crafter. Yorkshire Crafter says, evening, D Harris and Dave Mack Builds. D says, hi, good evening to Dave Mack. We've got Neil Ratcliffe. Evening to the Three Amigos. Hi, Neil. Hope you're well.
Hi, Neil.
Hi, Neil.
And we've got Dana's Universe. Evening, D. And what's the vibing?
Hello.
Yeah, hi. Sorry, I can't pronounce
that.
Hi.
D. Harris at Neil Ratcliffe for good evening. There we go.
Right, okay, so I'm doing the lesson tonight. So let's go over and learn about servos.
Yes.
So, lesson 9, servo. Overview. Servo is a type of geared motor that can only rotate 180 degrees. It is controlled by sending electrical pulses from your Uno R3 board. These pulses tell the servo what position it should move to. The servo has 3 wires of width. The brown one is the ground wire and should be connected to the ground part of the Uno. The red one is the power wire and should be connected to the 5-volt port. And the orange one is the signal wire and should be connected to the DIG 9 port. There it's just saying what we need for tonight. So we need the Uno board, we need the servo, and 3 male-to-male jumper wires. It's got a little bit of information about the servo. So it's a universal for JR and FP connector. Cable length is 25 centimeters. No load, operating speed at 0.12 seconds, 60 degree, 4.8 volt, 0.10 secs, 60 degree, 6 volts. Stall torque is 4.8 volts, 1.6 kilograms. Temperature is 30-60 degrees Celsius, that is. Dead bandwidth, 5 US. Working voltage, 3.5/6 volts. And then it's just got the dimensions and the weight of it in there. So this is the schematic for tonight. And then this is basically the wiring diagram for tonight as well. So that's what we've got all plugged in, where we've got it plugged in. So there's the example picture. So I need to stop sharing that one and share my other screen. This is why you need 3 screens. Right, so here's the code. Gosh. Right, so the program, it knows, obviously we're using a server because you've got the server highlighted there. And then it's called My Server. And then it's create server object to control a server. 12 server objects can be created on most boards. Variable to store the server position. So position 0. I assume that's reset position.
Yes, that's just telling it to start from 0. Yeah.
Yeah, and then we've got void setup, serial begin 9600. My server attached to 9, so that's 9 on the board. Because it says attaches a server on pin 9 to the server object. And then this is a really interesting thing. So we've got the void loop. For position 0, position equals 180 position plus 1. So that's going to go from 0 degrees to 180 degrees.
Mm-hmm.
And then my server right position delay 15 milliseconds. So that's saying stop at that position, 15 milliseconds, and then for position 180 equals 0, position equals 1, my server right, and then delay 15 milliseconds. Okay. Right.
Okay, so sorry, I just got to correct you very slightly. So in this instance, where it says it's going from 0 to 180, that delay is how long it takes to go from 0 to 180. So if you made that delay, say 5, it would sweep round a lot quicker. It won't pause it at the end of the travel, if that makes sense.
Okay. Yeah, it does make sense.
Yeah. So that's what that delay is used for in this instance.
Right. Okay. Right. So I'm all connected up. Let me just change camera. The only problem when you've got 3 screens is... Okay, so... If I do that, here we have the server, and I've got it all wired up. I had to include a library into this. Come around here a bit more. For the server, so I'm going to upload. See if it does anything.
I think that's where I include a library for mine.
Taking a while.
It goes.
So as you can see, that's now moving around. That's pretty awesome.
Works a lot better than mine did. I've had to change my servo for tonight because mine was a bit jittery and all over the shop.
Yeah. Right. This is a little bit... It's a cheap server. I mean, I know servos, and it's not,
It's
you
not
can
the
get
best.
better servos than that.
Mm-hmm.
Well, that's it working, in theory.
Yep.
Right, so let me unplug that. Should we change something?
Yeah, have a play.
Right. So, should we change the delay?
Yeah?
30 seconds? Should we double it? No, let's go to 100.
Okay.
That it might not like that. You might not. You try it. Try it.
Right.
Mm-hmm.
Try it for now.
Mm-hmm.
Right. Let's upload. Actually, it's done it. If I come... It's done it. It's just moving very, very slow now.
Yeah, that's right. That's okay.
So
I might have been a bit too high for it, but no, that's fine. Yeah, just that. So obviously, the higher the number, the slower it's going to go.
Yeah.
because that's now making the movement happen, and it's wanting it to do it within, you know.
Yeah. There we go.
Nice.
10 seconds.
So if I just stop sharing, there we go. Excellent. So let me unplug that. And that's tonight's lesson, really.
Yeah.
Let me do that. But I have got something else to show after Horlixs a little bit.
Okay. I'll just go through a bit of chat and then.
Yeah.
Right. So we've got Neil saying hi D. Violin says, "Where's the Apex at?"
I replied.
Yeah, and then Jack says, "On Wednesdays we have the code in the electronic stream." Yeah, that's right. And yeah, you said it's kind of unique. Daniel's Universe says, "Could you put that in a model plane with propellers or a helicopter or something with blades to make them rotate?"
Yes.
No.
Yes. Well, I won't put this servo in there.
No, yeah, you can do it, but not with this sort of setup. The servo only rotates 180 degrees. As you know, it's in remote control cars and stuff like that. So it's only got limited travel for, you know, your steering or your throttle or something, or whatever you want to do. So you can't make it spin. For that, you need a motor, which we'll cover on a later lesson, because they get a bit more complicated with the wiring up and stuff. So yeah, but I mean, if you want, I mean, I suppose you could use it for a model helicopter if you didn't want it to sort of spin as such. If you wanted it to give the impression it was moving really slowly and back, then you probably could. Depends what effect you're after. So,
but yeah, I'm quite impressed with it. Like I said, I wouldn't use this servo. This is too small for. This would be more small projects.
Yeah,
really. I would use better. This is a micro servo, and for like remote control cars and stuff like that, you need not a micro servo, but a more bigger one. So, well, that's the little servo. There we go. Okay.
Well then, who's next? Jack, are you doing something or?
No, I did the show, but my servo, I don't know, it was a bit dodgy. Like things kept sliding out, so I kind of had to hold it in place. And yeah,
Right.
I managed to do it though. I managed to do it.
Okay. Right. I suppose it's over to me. So
Yeah.
I'm just going to make some code, and we'll see what happens. So here is me. Let me share my screen. I'm sort of prepared, but not fully. There we go. So, servos. What I think we'll do. This is a new sketch, so we'll write something out. Then you can sort of see what we're doing. So yeah, as Mark said earlier, the servo needs a library, and it just makes things easy for us because it's already embedded into the, you know, the software. So it just makes life a lot easier. So I'll bring that down. First thing we want to do is we want to include that library so that we can operate the servo. So that's hashtag include, and it will go green. And then we want the brackets, but the pointy ones. And then we want to do servo.h and then the close bracket. It will go orange. That tells us it's been accepted. Next, we need to give the servo a name, which we can do just underneath here. So it just, as you know, we've covered on other lessons with LEDs and things like that, and buttons. It's good to name them because then you know what you're up against, especially if you're doing a large code or a large project, and it just saves a bit of confusion. I mean, for this it won't because we've only got one servo, but I think you can have like up to 12 servos. Yeah, so you know you want to name them so you know what's going on. So for that, we're just going to type in servo. It should go orange, which it has. Then we're going to name it. So let's just name it. Obviously not servo because it'll go orange, but let's do Horlixs servo, for example. Okay, so that is all you have to do to set up the servo. And then no, done it wrong, sorry. So then we want to do, after that, we want to do an int statement like we do with the you know, digital pins and all that. But we're going to do int POS equals 0, which is going to basically tell it that the servo is going to start from 0. And I'm waiting for, need to put them in. Yeah, so in position equals 0. So that's to store, right, so that's that. Right, cool. Then for the setup, we want to do the name of our servo. So that's Horlixs servo, because that's what we've named it above. And then we want to do dot attach. Oh, fucking spell. dot attach, and then in brackets, the pin it's in. So we'll use 9 as it is on the sketch that Mark showed us. Okay, so once we've done that, that is it for the setup. We're just going to do the loop now. So I'll just delete that comment out so we can have a fresh page. So all we have to do for this is really simple. It depends what you want it to do. So it's as simple as, I mean, obviously the lesson that Mark showed us earlier was doing a sweeping motion, so it would go from 0 to 180 and back down. If you want it to go to set increments, we can do that with simple code. So all we have to do is Horlixs servo, because that's what I've called it. And then we want to do dot write, because we want to write to the servo. And then we'll do open bracket, 0, close bracket, and yeah, semicolon. So that's going to tell it to go to position 0, which will be reset. And then let's put a delay on that. So we just type delay. And then as you know, the LEDs and everything else we've done, we can put in a time. So let's delay that for 2 seconds, which is 2000. So it should reset the servo to position 0. Then we're going to delay it in that position for 2 seconds. Then we're going to do, I don't know, let's tell it to go to 180. So all we do, you can guess, Horlixs servo dot write, and then we're going to tell that to go to 180 and then semicolon. Let's delay it in that position for a second. So we're going to go from 0, wait 2 seconds, then we're going to go around to 180. We're going to wait a second. I don't know, what can we do now? Horlixs, oh.
Just to let you know, Jack's got technical issues, so he's had to come out.
Okay. Oh, I didn't realise if you push the insert, changes the cursor so you can see it a bit better. Like an old an old acorn or something. Right, anyway. If we do Horlixs servo got right, well, let's tell it to go to 90 degrees, semicolon, and then we'll delay that for 2 seconds. So, and then it should restart. So then we can do, let's do something else. Horlixs servo got right. Let's do it at 45, for example. So it can be any number between, you know, in degrees from 0 to 180. So we can do anything. So yeah, we'll do that. We'll delay that for 3 seconds. And then let's finish up with Horlixs servo. Let's do, well, it's going to do 0 anyway, but so let's just do 25 to bring it back home. Delay that for a second. So the idea of writing this is just to sort of show you how to write it, really. Like if you don't want to do it in increments and you want specifics, this is just how easy it is. I know it once you get used to it. I mean, the hardest bit is probably setting up the sketch in the first place. But once you do your loop, you know, it's pretty self-explanatory, really, once you know what to write. So let's hope this works. So let me come back and I'll get you set up on the bench. We'll quickly wire this up. I've actually added some electrical tape around this to keep it in because I didn't want to undo the sticky plastic, so it kept falling out last week. So yeah, I've got my servo now. This is a Tau Pro, so it's the same brand as the one we got, except this is a G90S, and this just means it's got metal gears in it rather than plastic, so it's a bit better quality because my other one just didn't want to work. So we're going to do green as negative, red as positive, orange. We told the sketch it was going to go in pin 9. So then we can just plug them into the end of this servo. And unfortunately, Christine, there's going to be no explosions. Sorry. I know you wanted to blow it up. Okay, so here is the servo. I've put the arm on it so we can see the position. And then let's go back over and write the code. So let me just plug this in. And then we'll write code. Oh, something's gone wrong. There we go. Look, forgot the semicolon. And I've spelled servo wrong because I put a capital S there. Right, so let's try that. So it's just reset to 0. Went to 180. So it's just a bit random, really. So that's 0. 0, 180, then it goes to 90. Then it should go to 45, then 25, and then back to 0. 180, 90, 45, 25, back to 0. There you go. You see how it works?
That's awesome.
And that's as simple as it is. Like, say, you know, it's not actually that complicated, really. Obviously, it does get a bit more complicated when you're, you know, wanting to go from sweeping. There's a little bit more code involved, but on a basic level, this is all you need. And you can change the timings, and it depends what you want from it and what you're doing. And it's a shame because just before the stream, I said to Mark, like, I was telling you the story about this servo I've seen with a magnet on that was moving a forklift on a diorama. Those of you who watched Novel Model Builders Show, I finished my Mini. So I was actually I've got some really strong magnets. I was going to put one on the bottom and sort of show you this with the Mini moving around the table. But I can't find my strong magnets anywhere, so that'll have to be for another day. But that's just one of the uses you could use. And obviously, you'd have to slow it down a bit, which is actually something I'm not sure about how to do when you're writing this bit of code. I need to look into that. There should be a way of slowing the arm movement down. But just off the cuff, this is all I could come up with today. But yeah, that's it really from me. Just basic bit of code there to show you how it works.
Okay, right. Well, I'll do my bit. So on the Ecto 1, the front strobe lights don't do anything. There's no bulb in there or anything. And a lot of people on YouTube have been sort of modding it to for them to flash. So I thought, why don't I try doing it? So this was Saturday night, was it? Yes. So I wrote some code. First ever code I've written. So there we've got at the top, we've got white, and that's coming out of pin 13. We've got another bulb that's coming out of pin 12. I wanted it to continuously loop, so that's why it's on down the bottom. Put your main code here to run repeatedly. So pin mode white 1 is the output. Pin mode white 2 is an output. So digital write for white 1 is high. That's obviously switch on the bulb, then delay by 50 milliseconds, and then for white 1 again to go low, which is switching it off, and then delayed it by 500 milliseconds, and the same with the other bulb. So basically, that's what I'm telling it to do if it wants to do it. So let me come back. So wired it all up, put resistors in. Obviously connect to the board. Now there was a couple of problems with it, but I managed to work out what it was. So should work. It worked the other day. There we go.
Yeah. Wow.
Now I can take this, put it on a nano, and install it into the Ecto 1.
Brilliant.
Really chuffed with that because first time I've ever written code.
Yeah, well, that's it. And it's your first custom, freestyle, what you want it to do sort of thing. So, yeah, it's really good.
Yeah. So I've got all this saved, and then I can put it onto a nano board, put it in the Ecto one, and I can know that I've done that.
Will you have, do you think you'll start coding in a switch to make it come on when you push a button? Or will it just come on when
I'm gonna have to, because if I've got if it's connected to power, then yes. Or I can hook it up to the switch that's on the current lights on the Ecto one, and then I wouldn't need it then, basically. So that's probably what I might do, and then all the front lights come on at once. But I'm really chuffed with it.
Yeah, that's good.
So that managed to do it.
As you can see on the Arduino board there, as we said in other lessons, pin 13 is actually attached to the orange LED on the Arduino. So you can see there that when that bottom LED flashes, so does the light on the Arduino.
Yeah.
Because they're attached to the same pin.
Well, one other thing is, if I unplug this, 9-volt battery that comes with the kit. Obviously, it's still got the code written on the board. I can run it off a 9-volt battery if I need to.
Yeah.
So.
Well, that's it. And, as I suppose what we really said, like, you only need the computer to write the code and put it on. And once that code is in that board, in the microchip, that's it. It will stay on there until, you ever rewrite code and upload it to the board. Otherwise, that'll stay like that.
Yeah.
So,
that's how you can power it without the USB. Quite simple, but it's one of these things you have to get over your first time of doing your code.
Yeah. Exactly. Yeah, and you do it, and you do, like, you've done that, and then once you've got that down to a T, that's when you can then play and think, do you know what? I fancy a switch.
Yeah.
Then you can just keep that basic code, save it, and then open a new one, copy it, and then just have a play, and
there you go.
And then just keep progressing it and adding to it. You don't have to do it all in one go. So yeah, it's good. Yeah, well done.
It can actually be done, and it can be done by a novice like me. So as soon as I unplug that, it'll switch off. So yeah, I'm really chuffed at that. So if I change my camera to my stop sharing and then change my camera. So again, not a long one tonight. There we go. But I just thought I'd share that with everybody just to say, look, this is possible.
Yeah.
Especially by me, who's a complete novice. But
and obviously the joy of it. No, it is great fun just to play with it and just test your limits, I guess. But also, if you're doing like what Mark's done there with the lights, if you can hide that nano board somewhere that you can access it, there's nothing to stop you moving your model to a computer if you ever wanted to change it and freshen it up and do something different. As long as you've got access to the USB port on the board, you can plug it in, even if it's attached to your model. You'd have to obviously use the same pinouts and stuff, but if you wanted to change, like, how much, the flashing or whatever, or even add an LED somewhere if you can, as long as you can get access to the board, you can edit it and keep playing with it.
Yeah, I mean, like at the top, the variables, I mean, they're coming out of pins 13 and 12, but I could easily change them to pin 5 or pin 6 or whatever.
Yeah.
Really. It's quite simple to do. But I just thought I'd share my little bit of coding.
Yeah, do you know what? I've actually learned something from your code that you've written, because I always thought when you declare inputs and outputs, I thought they had to go in the setup section. But I noticed you've put it in the loop section,
Yeah.
and it still works. So I've learned something new there, because I thought that had to go in the setup. But by all accounts, it doesn't really matter where you stick it, as long as it's in there.
As long as you put your variables in the setup, and
Yeah.
the rest you just write out with the others. So I can't believe I taught you something, Alex.
Yeah, well, no, I didn't know you could do that. I guess I've never tried, but I'm just so used to writing it and
Yeah.
set up, LEDs, then write the loop afterwards. But there you go.
There we go. Right, do you want me to catch up on chat?
Yeah, if you want to.
Okay, we've got Yorkshire Crafter saying, could it be used on a windmill, small model, for example? So the servo.
Only if you want the blades to rotate 180 degrees and then back.
Yeah.
Not for constant. It doesn't work as a constant go round. That you need a motor for.
D. Harris says that one you just used, Mark, would be more in with a ship's rudder.
Yeah.
Yeah.
There you go, look, Mark. Might be a little mod for you.
I've got some. I'm hopefully going to turn the wooden Titanic into an RC.
All right.
Hopefully. Jay's channel says, good evening all. Hope everyone is okay and well. I will catch up with the show and Dozy, LOL.
No worries. Hi, Jay.
King Kong Ian says, yeah. And then I think they're having a talk thing, but then Jack goes, yeah, you good, bro. I don't get this lingo. The screen's a bit small. Yeah, man, thanks for joining the stream. It ain't, lad. No problem, pal. How are you doing? And then E. Don't know what that is. And then DS Models of Vinci says you could make your Terminator work with that servo. Yes,
you can. The kit that I can't remember his name. Oh my god, he slipped my mind. But there's the guy who done the mod for the Terminator to move the heads. Yeah, there's servos and things in there. So yeah, definitely.
Yeah. And then D. Harris said, I would rotate the Mini on a motor and give it the 360.
Yeah. Well, you could do that as well. Like if you had a motor and an arm, and you had the motor bang in the middle of a roundabout, you could have like a magnet underneath, making the Mini just go round and round the roundabout. Get a bit dizzy, but
yeah. Then next bits, I know moderators will be on it, so thank you, moderators. Alan Key says, is the nano board the same as the Arduino?
Yes.
Yes.
I will share the screen. I've already pre-planned that. There you go. Excuse the flashing. This is a nano board, so it's basically exactly the same, but just miniature. And it just allows you to, I mean, these pins are pre-soldered. So you don't have to have them. You get an unsoldered one because that makes it a bit bulky, but it just makes it really small so you can conceal that. And it's £2.49, so it's cheap. So one of them, you're looking at £2.50 per model if you want to mod it. That's how cheap it is. And you get obviously a different style USB, but that's just to upload the code. And then your power source is on the pins. So you would have to solder power to them. So yeah, that's all it is. And I think we can see that in relation to the plug's almost the size of the Arduino. So there you go. They're the same thing. It depends on what one you get. I think you can get even smaller ones than this as well. This is, I think, the full pin out on this one. And there's 12 pins.
You'd be able to get them for like micro soldering, wouldn't you?
Yeah. So you got your 12 pins there. So like tonight's show, we programmed it to pin 9. So you solder your servo onto pin 9. And then you've got your 5 volt there, and then your ground. And then somewhere I don't know where you put it now. You've got your input power, might be on the reverse of the board, where you attach your power. So yeah, there you go.
Yeah, cheap enough.
See, these ones, like for example, this one, you can see the pins. That just makes life a bit easier. If you want plug and play, you can just use like the female pins, solder these pins onto the boards, then you can just plug things in and take them out as you wish if you don't want to hardwire it in. So, you know, if you've got the room to do that, you know, you could do that.
For me, I'd want plug and play. You know what I'm like with a soldering iron.
Yeah. So then you've obviously got your wiring diagram there. Tells you what things do and
which is your ground and
yeah. So
I think that's what scares a lot of people, though. They think it's going to be really expensive to do, but it's not. And I think that's what puts people off. I mean, I'm new to it all, but you look at it and think, it's only a couple of quid for a nano board. And like LEDs and resistors, they're not expensive.
No.
So, you know,
No.
I think it scares people that it's going to cost an arm and a leg to do it, but it doesn't.
This is an even smaller one.
Wow.
Obviously, it's gone up a little bit more, and I believe J1 there in the corner. I think that's the power where you plug your power into. But yeah, this is tiny. You've only got 9 pins on this one. But that's just how, you know, that's how small they are. That's a micro. And this has been taken under a thingy. It looks like that image being done under a microscope. So
yeah,
you can just see, you know, how small they are. But yeah, anyway. But yeah, they are the same. Just some of them have got less pins, so it depends what you're doing.
Okay. Catch up on chat. So King Kong, I am sub to Jack. D Harris says gone. That's the people that are putting strange things in the comments. And then King Kong I am says, is there a possible cause of perhaps going to the lighthouse idea of using both codes?
Yeah, you can do whatever you want with it. So if you wanted, do you mean like the windmill? Do you mean have the windmill blades turning and lights inside? Or you can do what you want with them, to be honest. As long as you've got enough pins on your Arduino to write, you know, inputs to and stuff, you can do what you want. So if you want the windmill spinning around 100 miles an hour and a beacon on the top flashing and disco going on inside, you know, you can. You can do what you want.
Fantastic. Well, I think we've definitely covered it tonight.
Well, I think so.
Yeah, definitely. Next week is lesson 10, which is ultrasonic sensor module.
Cool.
So that looks really interesting. So I'm just looking at it now and I think we can have a play around with this.
Ultrasonic sensor. So actually, you might be able to incorporate that with your blinking LEDs you've done. So that when you put your hand in front of it, it starts doing it.
Yeah. So yeah, that looks quite interesting, that one. But yeah, that's next week. So sensor module, does that work when like somebody comes close to it or walks past it?
Sort of. It's yeah, you know, like the R2D2.
Yeah.
It's got the sensors on the legs so that it doesn't walk into anything. It's like a proximity sensor type thing.
Right.
I think it's,
yeah.
Hang on, what is it? Sorry.
Ultrasonic sensor module.
Yeah. So that's their ultrasonic. So yeah.
Okay, but we'll tackle that next week. Right, another bit of chat. While it's turning and lights flashing.
Yes.
I know what it means. You could use the flashing code that I'd done with the code that you'd done for it to turn and blink.
Yeah.
So
Yeah, you can.
Yeah. Okay. Right, well, I think we've covered everything. Unfortunately, like I said, Jack's had to drop out because he's had technical problems, but we'll sort that out for next week. So, yeah. So I hope everybody's learned a little bit about servos tonight and how Arduino can use them. So, because I've only ever done servos with remote control. So, D. Harris saying, good job, gents. Another interesting show. See you next week.
Thanks, Dave.
Thank you, D. So, I'll say my goodbyes first of all, if you want. So,
Okay.
thanks everybody for tuning in and watching us again, and continuing to watch us as well, sticking with us as we go through this. And yeah, I'll catch you on the next one. And for some strange reason, Horlixs has dropped out. Hello.
I didn't go anywhere.
I had visions of the hobby show then.
I've got a shortcut on my mouse on the side, and I accidentally hit it with the back of my thumb, and it's the back button on the browser. I was like, oh! Anyway.
Okay. Well, I've done my goodbye if you want to do yours.
Sorry. Yeah. So, yeah, thanks for watching, everyone. I hope you enjoyed the show. And, yeah, sorry, Christine, I didn't blow anything up for you, but I will one day. But, yeah, until next week. Yeah, take care.